In number 6, we have another rational equation. So we got a polynomial on top, the 1, and then divided by another polynomial on the bottom. This time the polynomial on the bottom is slightly more complicated than in number 5. So we'll just plug in our points, see what we get out. And when you do this, one thing that you'll notice is that when you plug in x equals 2, you get 1 divided by 0, which we can't allow. So there will be no y value there. So at x equals 2, we just put does not exist for the y value. Once we have the table filled out, we can sketch the graph. The x's that we've found y's for go from 0 to 4. So that's all on the right side of this graph. And the y's are pretty small. They go from -2 to +2. And we know at x equals 2 we can't get a y value, so we can put a vertical asymptote there. And then as you start to plot these points, you might notice that this looks quite a bit like what we got in the last problem for 1 over x. It's just that everything is moved over to the right by 2. And that's right, this graph looks exactly the same. It's just shifted over to the right by 2. The reason for that is because instead of 1 over x, you replace that x with x minus 2. And the -2 part tells you go over to the right 2. Just shift your graph over to the right 2. We'll talk more about that in another week. So the shape is a rational graph. The y-intercept is where x equals 0, and we found y equals -1/2 there. As you go out to the right, the y values decrease. And as you go out to the left, the y values are increasing up to y equals 0.